Electricity Part 2. Objectives. In this part of electricity, we are going to learn the reason for electricity's existence and the types of electricity. Matter is made up of atoms. It takes up space and it is everywhere around us. In our universe, there are only 92 to 98 naturally occurring atoms, and the rest are synthetic. These atoms can bond together in an infinite number of ways. A certain amount of each type of atom come together to form elements. The periodic table is a chart that organizes chemical elements into rows and columns. All of the elements in the universe can be found on the periodic table. Atoms contain particles inside of them. These particles are referred to as subatomic particles. The positive particles are called protons, the negative particles are electrons, and the neutral particles are neutrons. The existence of electricity is due to the existing attractions between electrons and protons. Unlike particles are attracted to each other, while like particles repel each other. Electricity is a form of energy resulting from the existence of protons and electrons either statically, which is an accumulation of charge, or dynamically, as a current or flow of charge. Static electricity arises due to friction and electrostatic induction. Rubbing or friction is a process by which electrical properties are transferred from one body to another due to physical contact, while electrostatic induction is a process by which electrical properties are transferred from one body to another without physical contact. In metals like copper and gold and aluminum, the positive particles are stationary while the negative particles possess mobility. In insulators like paper, plastic, and rubber, electron mobility and hence transfer is poor. However, when insulators are vigorously rubbed with another type of insulator in the right environmental conditions, the strangest thing happens. Electrons get rubbed off and they transfer from one insulator onto another. Depending on the nature of an object or substance, electrons either leave or accumulate on the object after it has been rubbed. The electron is the only particle that moves from one surface of an object to the next. A neutral object has no charge because it contains the same amount of protons as well as electrons. For example, when polythene, an insulator, is rubbed with a cloth, it becomes negatively charged, while the cloth, another insulator, becomes positively charged. On the other hand, when cellulose acetate is rubbed with a cloth, it becomes positively charged, while the cloth becomes negatively charged. On the right is a list of insulators. It starts with those that are more inclined to become positively charged, and this inclination to be positively charged decreases as we move down the list. Human hair becomes positively charged when rubbed with a rubber or plastic comb, which in turn becomes negatively charged, while vehicles become negatively charged due to air friction, while the air becomes positively charged. If a negatively charged rod is brought close to a neutral object, it will cause a separation of charge within it, as can be seen with the aid of the balloon. This is an example of electrostatic induction since no physical contact has been made. The same thing happens if a positively charged rod is brought close to a neutral object. It will also cause a separation of charge within the balloon. Throughout this lesson, we will refer to different types of positively charged particles as well as different types of negatively charged particles. The positively charged particles are protons and cations, while the negatively charged particles are electrons and anions. The proton and the electron are subatomic particles that can be found in the atom. The proton inside of the atom will be found in the nucleus, while the electron inside of the atom will be found in the energy shells, energy orbitals, or energy levels. The cation and anion were once atoms that either lost electrons or gained electrons. They can be found in the air, electrolytes, and plasma. Problems and hazards of static charge. We have electrostatic shock, attraction of small particles, explosions due to sparking through flammable gases, and lightning. Let's explore. Electrostatic shock. In dry conditions, if you walk across a carpet barefoot, you become positively charged as electrons leave or get rubbed off of your body. And if you come into contact with a metal doorknob, which would have become negatively charged due to friction, you will receive an electric shock as electrons transfer from the doorknob into your body and then into Earth. Earth is filled with positive and negative particles. This is why it is a natural electron sink or source. Charged objects like the TV to the right attract dust and other small particles, including bacteria, because they induce an opposite charge on them. This is why equipment like computer screens and hospital equipment should be connected to Earth so they constantly discharge to remain neutral. Explosions due to sparking through flammable gas. Dangerous explosions can occur when flammable gases come into contact with sparks produced as electrical charges jump between oppositely charged bodies. When adding fuel to a car, the metal nozzle at the end of the hose is placed into the gas tank and hence comes into contact with the car. To stop this from happening. Lightning. A cloud becomes charged due to friction between the air, water droplets, ice crystals, and hail, rising and falling in convection currents within it. The base of the cloud generally becomes negatively charged and the top positively charged. Sparks can occur between opposite charges within the cloud. Negative charge at the base of the cloud repels electrons from the Earth's surface, resulting in a net positive charge accumulating at the surface. When the potential difference between the Earth and the base of the cloud is sufficiently large, electrons and negatively charged ions rush from the cloud to the ground. These high-speed particles crash into neutral air molecules, knocking electrons from them and creating pairs of positively charged ions. The result is an avalanche of positively and negatively charged ions rushing to the cloud and Earth, respectively. The discharge current is typically in the range of 5,000 to 20,000 amps, but can be significantly higher. Electrical energy transforms into heat and light energy, which is seen as lightning. and which transforms further into sound energy as the air rapidly expands, increasing the pressure and producing a sonic shock wave we call thunder. Useful applications of static charge, lightning conductors, and electrostatic spray. A lightning conductor consists of one or more metal spikes connected by a thick metal strip to a thick metal plate buried below the surface of the earth in damp soil. The metals used include copper and aluminum, which are both good conductors of electricity. Tall buildings are vulnerable to lightning strikes since they can be close to clouds, so lightning conductors are fixed to high points on these buildings. The negative charge on the base of the nearby cloud induces positive charge at the spikes. This positive charge is highly concentrated due to the sharp curvature of the rod and spikes and creates an electric field strong enough to produce point action that ionizes the air nearby. Positive ions produced rush to the base of the cloud, reducing its negative charge and making it less dangerous. The negative ions rush to the spikes and the rod, where they readily conduct to the earth via the thick conducting strip and plate. Should a bolt of lightning strike directly at the rod, the electrons will easily conduct through the thick conducting strip and plate and so avoid passing through the building. If lightning strikes a building which is not protected by a lightning rod, the charge flows through the moisture in its structure, instantly vaporizing it to produce strong pressures which can break it apart. Point action. The charge on a conductor resides on its surface, and it is most concentrated on sharply curved surfaces, especially around wires and points. The negative base of clouds induces a positive charge on the land and on tips of trees and on the tips of boats. Insecticides, herbicides, and fertilizers can also be applied by electrostatic spraying. A solution of the chemical to be used is sprayed as a fine mist onto the plants, where it sticks firmly to the leaves and stems due to the opposite charge it induces. The droplets are negatively charged by friction as they leave the spray nozzle. As they approach the leaves of the plants, they induce positive charge there and are attracted. Dynamic electricity refers to the flow of electrons through a conductor in a closed circuit. Metals, graphite, and electrolytes are types of conductors of electric charge. Examples of metals include gold, aluminum, and copper. Metals and graphite are able to conduct electricity because they contain mobile electrons, while electrolytes contain mobile ions. The matrix of metals contains a sea of delocalized mobile electrons. When these electrons are supplied with enough energy or force, they flow through the metal to provide an electric current. Graphite is used every day as your pencil point to write with, and it is also used to lubricate machinery. Each carbon atom in graphite is joined to only 3 other carbon atoms. Weak forces hold the layers of the carbon atoms together. An example of an electrolyte is salty water. Conductors that are electrolytes conduct electricity because they contain mobile ions within them. Examples of electrolytes are strong acids like hydrochloric acid, weak acids like citric acid, strong bases like sodium hydroxide, weak bases like water, and regular salty water. When salt is added to water in its solid form, it dissolves and breaks apart into mobile ions. For instance, if sodium chloride is added to water, it would break apart into sodium ions and chloride ions. Positive ions are referred to as cations, and the negative ions are referred to anions. Let's remember this. Examples of cations are sodium ions, calcium ions, potassium ions, and magnesium ions, while examples of anions are fluoride ions, chloride ions, nitride ions, and sulfide ions. Please note that the size of the ions are not a true depiction of their size in comparison to each other. In a process known as electrolysis, electrolytes or molten ionic substances conduct electricity by completing the circuit to make an electrolytic cell. Electrolysis involves using electricity to break down electrolytes to form elements. The flow of electricity in this system is due to the presence of both mobile electrons in the wires and mobile ions that you'll find in the electrolyte. During electrolysis, the cell powers the electrolytic cell and forces electrons into the negative electrode, which is the cathode. Cations are attracted to the cathode. The electrons enter the cations, transforming them into their elemental state. The anions are attracted to the anode. They give up electrons, which causes them to return to their elemental state. The electrodes may either be made of metal or graphite. Comprehension. What is matter composed of, and what is the periodic table? You may pause this video to answer these questions. Matter is composed of atoms. The periodic table is a chart that organizes chemical elements into rows and columns. All of the elements in the universe can be found on the periodic table. Comprehension. Complete the table below. You may pause this video to answer this question. Correct. A proton is positive and can be found in the nucleus. An electron is negative. It can be found in the electron shell, the electron level, or the orbital. A neutron is neutral, and it can be found in the nucleus of the atom. Comprehension. Label the structure below. You may pause this video to answer this question. Did you get them all correct? Good job! Comprehension. What are the two types of current and describe their differences? You may pause this video to answer this question. The two types of current are static electricity and dynamic electricity. Static electricity is an imbalance and an accumulation of charge upon an object, while dynamic electricity is the flow of electric charge through a conductor within a closed circuit. Comprehension. Complete the table below. Categorize the following as either a conductor or an insulator. You have glass, graphite, wool, copper, fur, and salty water. You may pause this video to answer the questions. Did you get them right? Very good. Comprehension. Explain why conductors are able to conduct electricity while insulators can't. Explain why insulators are neutral. You may pause this video to answer these questions. Conductors can conduct electricity because they contain either mobile electrons or mobile ions. Electrons are bound in insulators, hence they are unable to conduct electricity. Insulators are neutral because they contain the same amount of negative particles as well as positive particles. Here is an oversimplified picture for this explanation. The balloon contains 6 positive particles and 6 negative particles. If you add them together, you get a value of 0, which means that the object is neutral. Comprehension. Give 2 examples of positive particles and give 2 examples of negative particles. You may pause this video to answer these questions. Protons and cations are examples of positive particles, while electrons and anions are examples of negative particles. Comprehension. What are 2 hazards of static electricity? And provide 2 applications of static electricity. You may pause this video to answer these questions. Lightning, electrostatic shock, and explosions due to sparking through flammable gas are examples of static electricity, while spray painting a car and the mechanism of photocopying machines are 2 applications of static electricity. Comprehension. What is the structure below and how is it able to conduct electricity? You may pause this video to answer the question. The structure is graphite. Graphite is able to conduct electricity because of how carbon is bonded, leaving free and mobile electrons to roam the matrix of graphite. Comprehension. Give 3 examples of an electrolyte and how are electrolytes able to conduct electricity. You may pause this video to answer these questions. Three examples of electrolytes are salty water, hydrochloric acid, and sodium hydroxide. Electrolytes contain mobile ions, which is why they are able to conduct electricity. Comprehension. Label A, B, C, and D. You may pause this video to answer the question. Did you get it right? A is the cell, B is the anode, C is the cathode, and D is the electrolyte. Alright, I hope that you enjoyed this lesson. See you soon!